This is Jack Jackson. In this video, we're going to be talking about Geometer Sketchpad. We're going to be using a sketch that I created to give an introduction to many of the features of Geometer Sketchpad. Before we get into that, let's take a quick look at what it takes to purchase Geometer Sketchpad. If you'll go to www.keycurriculum.com, you'll get to a site where it talks about Geometer Sketchpad. And it talks a little bit about how you can download a free preview so you can try it out yourself there. So if you have access to this sketch that I have here, you could download the free preview, open the sketch in that, and experiment with it for a few minutes, like 20 minutes, and kind of check things out. But we can also talk about pricing a little bit very quickly. And as of this time this is recorded, of course these are subject to change, but there are two basic ways you can get Geometer Sketchpad. It's still full version in both cases, but the non-expiring license depends on the number of computers that you purchase it for. So if you're just doing it for one single computer, the current prices are $70.02 a piece. For up to 4 computers. But if you're buying for a group of people, like a group of students wanting to get together and buy these, or if you're buying them for a classroom or something like that, 5 to 19 computers, the price drops down to $30 a piece. And you can see there are different stages here, but it works its way all the way down to $15 a piece for 100 or more computers. Now, what this does is allows you to have a non-expiring license, so this is you have a license to the software basically forever. Now, there's also even cheaper prices if you just want sort of to rent the software. So for 1 to 29 students, you can rent it for $9.96, and that gives you a 1-year license. So if you just wanted to buy this, say for one school year or for 1 or 2 semesters, you could get this software like that. So at $10 a piece or even cheaper if you've got more students doing it, it's not too expensive to get into the software, particularly if you're only going to use it for 1 semester. So for example, in my courses like trigonometry, which I use Geometer Sketchpad quite a bit, those students are not necessarily going to be going on to be using this a lot in the future, perhaps. I suggest that they maybe just spend the $10, or if we can get a whole class of 30 of them together, $6 a piece to rent the software. But for math majors who I think should be using this software quite a bit in multiple classes and perhaps even in their careers later on, they might get together in a group of them and buy a perpetual license. Now, onto my sketch. This particular sketch has been created to give an introduction to all the basic features of Geometer Sketchpad and several of its more advanced features as well. And the idea is to work through these tasks that I have in these different tabs, and by the time you get to the end of this, you'll be pretty proficient at Geometer Sketchpad. In this particular video, we're going to be going over some of the most basic features, and we'll go through the first a few tabs here together, and then if you have access to my sketch, you can work through the others on your own. So just as an overview, Geometer Sketchpad is designed to create dynamic geometric figures with certain properties that are constructed into the figure, while other properties can be freely manipulated. So with Sketchpad, we can create accurately constructed illustrations which can be manipulated to give many examples. We can investigate conjectures and use Sketchpad to create counterexamples to prove a conjecture wrong. We can use Sketchpad to lead to the discovery of conjectured properties and mathematical concepts, and by constructing such a large number of examples, we can test out conjectures and give ourselves a level of certainty well above the level of creating one or even a few examples, even though this is short of a deductive proof. But Sketchpad can be used to lead us to the key ideas of a proof, and then When you even write a proof, you can use Sketchpad to illustrate the steps of that proof. So Sketchpad is a wonderful tool for visually investigating and illustrating a wide variety of mathematical topics. Of course, these include topics and figures from Euclidean plane geometry, sort of its native language, but they also include topics from other areas such as non-Euclidean geometries, arithmetic, trigonometry, algebra, statistics, pre-calculus, calculus, and many other areas of mathematics. These topics range from the most basic, such as elementary geometry and arithmetic, to graduate and postgraduate level topics in mathematics. In fact, Sketchpad can be effectively used in nearly every course in mathematics. Some sketches are easily created by novice elementary school students, and more advanced sketches can also be created to suit the purposes of the expert investigator. Given enough creativity, effort, and time, the possibilities are nearly limitless. So the idea is you go through this sketch a little bit at a time here, and as we're going through it, we will see different tools and how they use. We'll start with the most basic and then work our way up to a little bit more advanced. By the way, I just put this picture in here to show that you can embed pictures. And this is all based on Geometer Sketchpad version 5, which was released in the fall of 2009. And the tutorial is designed for that version. And for example, I can embed links. I can put text, as you can see here, format that text, as you can see, and then we can continue to the next tab with a link, hyperlinks that are built into it. So what are the uses of Sketchpad? Well, one thing we can do is create accurately drawn objects. And we can use these to create static versions of drawings for exams, homework sets, class notes, group projects, etc. So one of the things that we end up doing, at least I know when I'm teaching math classes and I'll draw something by freehanded on the board, sometimes it doesn't really accurately represent what I'm trying to draw. But if I can generate it in Sketchpad, then it will have exactly the figures drawn to scale, exactly how they should be. And sometimes that's very important for getting a better idea of it. So I can use it to demonstrate ideas in class. And so if I have a projector or smartboard, I can use it to demonstrate in class, but I can also use it to have students interact with the sketch, or me interact with it as part of a group discussion. I can use it for group projects with students sharing a single computer. I can use it for individual projects with one student to a computer, either in a class, a lab, or at home. I can make advanced sketches that, although they may be difficult to make, they're easily manipulated. And there are many sources for such sketches. I've made several of these types of sketches that I use with courses such as arithmetic courses for elementary school teachers and so forth that are very basic tools to manipulate them, so I don't have to teach those students a lot about Geometer Sketchpad. For example, certainly after they've gone through a few tabs of this tutorial, they're ready to manipulate those sketches. And yet those took me a long time to and some advanced knowledge of Geometer Sketchpad to make. There are some subscription services called Sketchpad Lesson Link, and you may also find some other sources of Geometer Sketchpad sketches online. So a lot of these have complete lesson plans and sketches, directions, and so forth that you can download. Some of these things you have to pay for, others are free. They dynamically investigate mathematics. They look at dynamic generalized examples to help develop conjectures and connections among mathematical concepts. One of the important things is that we need to start thinking of our canonical example of certain figures as being a dynamic thing and not being a static one. So when you hear the word trapezoid, you don't just particularly think of a particular kind of trapezoid, but rather a general trapezoid, and Sketchpad can help with that. We can test out conjectures. We can find counterexamples to those conjectures. We can establish a level of verification much stronger than a few examples, but still short of a proof. We can investigate ideas that lead to a proof. and document and illustrate the steps of a proof. And we can use Sketchpad to investigate ideas from every mathematics course in the K-12 and undergraduate mathematics curriculum. So let's start with some basics. When you open Geometer Sketchpad, when you open it up to begin with, you're just going to see a blank page here, but you will see this little icon-based menu bar on the left and a text-based menu bar across the top. So let's start with the very first one. We can click on the File menu and notice that you see a lot of things here that you would find in any file menu. Create a new sketch, open an existing sketch, some links to some online resources here, save, save as, close. We'll come back to document options later, and so forth. Some things about previewing and setting stuff up to print, or actually you can quit Sketchpad here. Of course, like any Windows program, you can go up here and click these things here. By the way, I'm using a Windows version here, but there's a Mac version that works very similarly. I want to point out one of the most important features right away is under the Edit menu. So notice you have things like copy, paste, cut, and so forth. We'll talk about action buttons later and so forth. And there's several different things here for setting up preferences and properties. The things I want to point out are some of the things that we have shortcuts for, and they're the same as Windows shortcuts. So cut is Control with X, copy is Control C, paste is Control V. Those are standard Windows shortcuts. But then probably the greatest thing ever invented in computers is the undo button. So you can do Control Z as a shortcut to that, and Control R is the redo button. So if I were to come here and accidentally delete that, oh, I didn't mean to do that, I can do Control Z and all is fine. And so that is wonderful. That allows you lots of freedom, because that allows you to go in and just kind of experiment freely and knowing that you can get back out of it. One thing I do want to mention under Save that Geometer Sketchpad currently does not have, and that is an auto-save feature. For example, I get really used to that in Microsoft Office, that I know that it's going to save every few minutes or however long I set it, so that I can never lose too much work. But I have lost lots of work in Geometer Sketchpad. For example, when my battery went out and ran down in my laptop computer, and I hadn't saved for an hour, and that was a big mistake. So you need to get in the habit of saving fairly often. So you need to actually do that by doing, File and Save, or Control S is the shortcut to that. Notice I have these action buttons here, and when you click on those, it will take you to it'll do something. In this case, it's a link to the next tab. Now, let's talk about some of the most basic tools. So over here on the left, you're going to see the most basic tools in Geometer Sketchpad. And so what we're going to do with this particular page, and this is going to be typical throughout this sketch, we're going to have a series of action buttons here. We'll read some text, do what it says in that text, and then we'll turn that off, hide it, and then show the next one. If I don't hide it, notice that we have a kind of a big mess there where we can't read it. So we'll be sure to hide that before going on. Now the most basic button is this very first one, the selection arrow tool. Now oftentimes you're going to be going back to this, after you use some other tool, you're going to go back to select the selection tool, and then oftentimes when you do something from a menu or from something over here on the side, things will be already highlighted. Okay, if you want to deselect those, just click out in the open space. Okay, now let's look at some things that we can do with this selection button. We can click on a point, for example, and then I can just move that around. Okay, if I click on this line segment, that line segment is just being translated around, but notice the other line segments being based on these points here, the endpoints, which are moved with the line segment, they are dynamically adjusted. So notice that this is what I would call a general triangle. Okay? By moving it around, I can get any triangle, but it always stays a triangle. Well, I guess except for when it becomes a line segment there. It always stays a triangle otherwise. But I could get any triangle out of it. So that's a general triangle. Okay, we can also select multiple points by going out here, and then I can, for example, I could delete that, or say I don't want to do that, Control Z, get it back. Or I can just take the whole thing and move it around a little bit. So I have, you can select multiple things by highlighting them with a little box like this. So there's the whole triangle, including the vertices. Okay, so let's hide that. Look at the point tool, the second one here. Now look at this. Now I'm going to go back to the selection tool, and let's look at this particular thing, this particular line here. Notice we have points B and C on this line. Well, are they or are they not? Well, point B is actually on the line. It only, in fact, it's one of the control points of the line, so that it always moves up and down the line. But I think you can already see that point C is actually a free point. It's not selected on the line, even though it may temporarily be on the line. It's not a point on, it's a free point. It's able to be moved off the line. So we can generate points with the point tool by creating free points like this, and then select the arrow tool to move them around. But if I want them to be on the line or some object, I make sure that, see how that line lights up, and I click on it. Now that point is selected not as a free point, but as a point that can only move up and down the line. I don't have the ability, so I'm trying to move left or right here, and it won't do it. It only moves along. I can't move it in any other direction except the line. It stays on the line. So that point is constructed as a point on the line. Notice as I use the control points of the line, that point moves with it so that it stays on the line. Okay. So you should experiment with these things yourself, okay, as we go along. I'm going to get rid of these extra points here. Next thing is the compass tool. So it looks like a little circle. So we can click on that, and what this does is you click here, click 2 points. The first one is going to be the center of a circle, and the other one is a point on the circle. Notice as we do that, it leaves the circle and the last point highlighted. Okay, so when I click here, if I click down here on something, sometimes it will make things, sometimes it will unhighlight things and sometimes it won't, depends on the situation. Notice that if I move this point here, the center of the circle stays the same, but I'm changing the radius as well as the position on the circle itself. If I move the center, since this point on the circle stays fixed, so we're moving the center and also actually changing its radius as well. Okay, so this is very similar to what you would do with a compass. If you think about classical construction tools, you pick a point and you pick a radius and then draw an opening for your compass, and you draw a circle with it. So we have the ability to mark points and to use a compass. The other thing that you do with classical tools is that you have a straight edge. And we have a straight edge tool here. Notice we can use it to make line segments. I click on 2 points and we have the line segment between. Notice again, these can be these are dynamic. They can be manipulated. So it changes the 2 endpoints of the line segment. Now we also have the ability, if you click down here in the corner, there's a little arrow, and the tools that have little arrows here, I'll get to it here. Okay, there it goes. I can now turn this into an array. Now, if you were to print this out, you'll see it will, of course, obviously have to stop somewhere, and it gives a little arrow on the end. But the first point you click on will be the end point of that ray, and the second one will be another point on that ray. And so this ray goes on forever in one direction. And then you can actually have it do the same thing, but make it a full line. And so this line is determined. Well, all three of these things are determined by 2 points. And you can make line segments, lines, and rays. Okay. Now let's see if we can make a triangle. Okay, so triangle's made up of line segments. So select a line segment, and what we can do is we can click a point, click another point. Now click one of the endpoints, click another one. Notice we're still on the line segment tool, so it's assuming we're still wanting to make line segments. Click here, and then make sure that this one clicks back on the original one. Now, by doing it that way, we've identified the endpoint of the last one with the first endpoint of the first one, and we see that we now have a dynamic triangle. Now we have another way to make triangles or other polygons, and that's with the polygon tool. Okay, now see, there's an example where I need to make sure I click on the selection tool there before I go on. I'll delete a few things here. Now let's go back to the polygon tool. Okay, now with the polygon tool, there are actually 3 options here. We can make the interior of a polygon and its interior, or just a polygon. So the way the polygon tool works, you just click on the endpoints like that, for example, to make a quadrilateral. You can also click on, do this one, and it will make the polygon and its interior. Let's make a pentagon this time. And you can just click on this one, and this one will make just the interior of a polygon. Notice your last click needs to be on the place that you started with. So notice this one this last one you see the interior of the polygon only. You don't see the polygon itself, the sides of the polygon. This one has the polygon itself along with its interior. This one just has the polygon only. Okay, now let's look at the marker tool. The marker tool is the next one down. I'm sorry, I skipped one. The text tool. Let's do that next. Now the text tool, the letter A here, allows us to label things. So for example, I can click on a point here, and it gives it a name. If I double click either on the letter or the point or the object itself, I can go in here and rename this. Say maybe I want to rename that point A. You know, I can name this one Fred if I want. I can name it whatever I want. Okay. Now you can label a, maybe not Fred. How about just F? Okay, and so I can name line segments. This L is the line segment here. This K is this line segment. Notice when I click on the letter, it shows me, it highlights what object it actually is. And so I can name things. Now another thing I can do, if you notice I have these text boxes everywhere, I could just highlight an area and type in some information there, like this is a text box. Now notice I have this stuff down here at the bottom, which may or may not be visible to you, but if you go to display and you show, you can hide the text palette, or I can go to display and show the text palette right down here. And what that allows me to do is, for example, I can take part of this, even just one word, I can change the font. I don't know what fonts I've got. So anyway, I can change it to some font there, and then I can also change the color. I can make it bold or not. I can make it italics or underlined. And I also have, I push this little symbol thing, this allows me to create some symbols. Like if I have AB and I want to, in geometry, AB means the distance between points A and B. But if I do like this, now it means a line segment AB. Okay, and then you have to click out of it to not be underlined, or have a line over it. Or I might have CB and make it array with the endpoint C. That would be like this. Okay, or maybe line XY. So I could take XY, do this, and make it a line. And similarly, I can do arcs. I can also use this to generate things like fractions. We could also put in, square root. We can put in powers. Like that, so forth, and parentheses, and there's a degree symbol, and an angle symbol, pi, congruent symbol, and then there's a list of a whole bunch of other symbols that we can use here. Other symbols would have to be obtained via basically from certain fonts. But there are a lot of basic things that you can set up there and make text boxes. So lots of cool stuff that you can do there in a text box. Okay, the marker tool is the next one. This little looks like a marker, right? And so I can click on that. If I click on a side, so this particular one is being constructed as a parallelogram. It turns out parallelograms have opposite sides congruent. So we often mark that those are congruent by marking them with a mark like that. Now we could also mark that these sides are congruent. However, that would indicate all three are congruent. That's not what we want. So if I click it again, I'll get a second mark, and I can do that as a second mark here. So we can do it that way. Another thing that we have about parallelograms is opposite sides are parallel. So I could mark this side this way. If I right click on it, I can change it to a mark like that, and that would indicate those are parallel. And I can indicate these are parallel. I have some different options here. For example, I can go to Properties and Marker, and I can say Open Arrow, but I want it with 2 strokes. And I can go forward or backward. And I could do the same marking with this one. And so that would mark those as being parallel as well. So we can put some different marks on there, and there's some other options as well. You could experiment with those. And another one is the information tool. That's this one right here. And the information tool is interesting. If we click on certain things, it tells us something about those. For example, this says point M is an independent object. That means I should be able to move M anywhere I want. Now, some of the other things are based on M, so they may go with it. But M itself can be moved anywhere we want. We'll see that K is also independent, and L is independent. So those 3 points are actually the control points that determine this figure. The point N, in contrast, is not independent. It's the intersection of parallel line 20 and 21. So this is a line that's a line segment that I got. I first had some parallel lines here that are hidden, and then this one connects the points there too. But I can, for example, click on this, and there's the line that was parallel to KL, and there's the line that was parallel to MK, and the intersection of those is N. Once I had the point N, then I made this. So that kind of tells you how this particular figure was constructed. Sometimes that comes in is useful. So now the last one is a custom tool, and I'm going to consider a custom tool as being a more advanced tool. So I'm going to save that for a later tab. Next, we're going to talk about drawing versus constructing. Okay. Now, I use those two terms in the following way. So you may draw something, and it may look like it has a certain property to begin with, but unless that property is built in, then it doesn't actually have that. So, for example, if you look at this, the way this is set up here, we have, it looks like, 3 equilateral triangles. And at the moment, I think they either are or very close to being are equilateral triangles. Now, this last one really is an equilateral triangle. And it's constructed that way, and I've hidden some of the things I used to construct it, but it is made so that it always stays an equilateral triangle. So this is a general equilateral triangle. It always stays equilateral. This one, the two red sides are always the same length, and you see that this is an isosceles triangle. It always stays isosceles, but definitely not necessarily equilateral. And this one here always stays a triangle, but it's a general triangle. It's not necessarily isosceles and not necessarily equilateral. Now, if the task was, for example, to make an isosceles triangle, the general triangle would not be appropriate because it does not have the appropriate amount of structure in it. Okay, so even though it may temporarily look like it has two sides that are congruent, when we manipulate it, we do the drag test, we manipulate it, we see that it's no longer isosceles. So in that case, if the task was to make an isosceles triangle, this general triangle fails because it does not have enough structure built in. On the other hand, if the task is to make an isosceles triangle, and we built this one on the right, then it fails also, not because it's not isosceles. An equilateral triangle is isosceles, but we've built in too much structure because not all isosceles triangles are equilateral. Okay, so this is a certain subclass of isosceles triangles, but doesn't give us a general isosceles triangle. If the task was to make an isosceles triangle, then this triangle here is the one that we want because now it makes any isosceles triangle. And similarly, we have here, this is a general right triangle, this is a right isosceles triangle. This one can be manipulated to form all right triangles, but then when this one's manipulated, it only has a right isosceles triangle. Now, suppose I wanted to make a copy of this. Now, one of the things you might say, okay, well, let's just copy it. Control C, come down here, Control V. Well, that's the same size, right? We just made a congruent copy. Well, yes and no. At the moment, what we did is this is originally is a general right isosceles triangle. What we made by copy and paste is another general right isosceles triangle, but it's not necessarily congruent, because now I can change that one. This one's not manipulated, and you can clearly see those are no longer the same. However, notice that this one over here is constructed in such a way that it depends on this one right here. So as I manipulate this triangle, notice that the other one is manipulated with it so that it always stays congruent to it. This one, notice I cannot manipulate the corners other than just to translate it, or perhaps maybe rotate it around. Okay. But I can't really change the shape of it. The controls are over here on this one. But as I change this one here, the original one, the congruent copy goes with it. So if you want to construct something that's congruent, you need to build that in. So this is a big important thing about Geometer Sketchpad, is that you always talk about what's there in terms of what's built into it. Be sure that you build in enough structure, but not too much. Now under the display menu, there are lots of different things that we can do. We can change the style of, there's basically 4 different sizes for a point. For a line, we have 4 different thicknesses and 3 different styles in terms of solid, dashed, or dotted. We can change the color of objects. These are the ones that are built in, but you can actually go to other type of objects, and you can actually define color based on a parameter. We can, with text, if we have text selected, let's see, display. Then we have some fonts here, and we have a few other things that we can control. But I also showed you that we have the this little text tool bar down at the bottom where we can pull up to manipulate text as well. Okay. So anyway, I'll let you experiment with that. Now this next tab here on Basic Constructions has 7 different tasks, and the idea here is if you go through this has a sort of a cookbook type of thing, set of directions that tells you exactly what to click to make these different objects. If you will go through and do these one at a time and go through the steps, I think you will begin to see how some of the other construction tools work, and you will see some of the more interesting things. For example, this first one is going to be able to construct a centroid of, or center of mass, the centroid of a general triangle. And there's what it should look like when you're done. But if you'll go through these steps, it will go through and show you how to construct it. Once you've done that one, then try the right triangle construction and so forth. And so if you'll work your way through all of these, then you will become familiar with the basic tools of the Geometer Sketchpad. In general, you want to basically work through each of these tabs, left or right, and then from one to whatever within each one. The next tab after that talks about basic transformations, which are mostly under the Transform menu here. And we can talk about those different things here. We all can also talk about measurements. I think some of those were under basic instructions. So you have different measurements that you can make, measuring lengths and distances, perimeter, circumference, angles, arc lengths, and so forth, and coordinates if you have a coordinate system. Under number, we can create parameters, and we can do calculations based on those parameters. And we can do graphing as well. Okay, and so there are several different things that we can do here. So again, work through these on your own. This one talks a little. This one here talks a little bit about some different things we can do with graphing. So we can do some basic graphing with that. Here's a basic task to take you through a few things about graphing. You notice I have these little action buttons that I've been clicking on, like these guys here. And this tells you how to create an action button. Particularly hide show buttons are interesting. It's one of the ones I've been using. We also have animation buttons. We can make custom tools to do our own thing. This talks a little bit about how to use those. Some of the powerful things about iteration, a couple of cool and more advanced things, how to make Java sketches, and it talks a little bit about the help menu. Then finally, I end with a series of more advanced sketches. I've got, looks like 5 of them here that are more advanced sketches that I've made that you can manipulate. These take a little bit more advanced understanding of Sketchpad to build them, but it shows you how you can manipulate some existing things. And these are there really just to show you some of the power of Geometer Sketchpad and some of the more advanced things that you can do with it. So hopefully that gave you a quick introduction to Geometer Sketchpad. Now hopefully you were able to follow along with me and try some of these things on your own. And then you'll be able to work through these tasks if you have access to my sketch. And by the end of it, you should be pretty well set up to continue on working with Geometer Sketchpad on your own.